Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, here we are required to evaluate the projections of the oblique plane which happens to be inclined with respect to both the reference planes, that is vertical plane, as well as the horizontal plane. So here we have been provided with a plane figure into which we are going to have a square hole over here. This lamina is resting on edge PQ onto the horizontal plane. And another situation which is provided to us, that the surface of this lamina, it happens to be inclined at an angle of 30 degree with respect to the vertical plane, and we are going to have the side PR is further inclined with respect to HP at an angle of 45 degree. So we are required to draw the orthographic projections of this particular lamina. Now, since the surface of the lamina, it is inclined at an angle of 30 degree with respect to the vertical plane in the first instance. So to begin with, we are going to assume that this lamina will be first of all parallel to the vertical plane. That is, onto the vertical plane in the front view projection, we are going to obtain the true shape projections of this particular lamina. And these true shape projections drawn on the vertical plane, they will be drawn above the XY reference line with edge PQ resting onto the ground. And when we are going to look at this lamina from the top side, we are going to obtain the edge view projections of this lamina obtained onto the horizontal plane, and these edge view projections will be drawn below the XY reference line. Now let us proceed with the construction of the orthographic projections of this lamina. So here, as discussed, because the first angle of inclination of the surface of this lamina happens to be with respect to VP, so to begin with, we assume that this lamina will be located parallel to the vertical plane. So we are going to obtain the true shape projections of this lamina onto the vertical plane in the front view projections, and this edge PQ should be resting onto the ground. So here we have got P dash, Q dash, R dash, S dash and T dash. So these are the 5 points which are going to define the boundary of this particular lamina. And here within this boundary we have got the square hole which is measuring 25 millimeter edge over here. So the 4 points corresponding to the square hole, they have been labeled as A dash, B dash, C dash and D dash over here. Now, having obtained the true shape projections of this particular lamina onto the vertical plane in the front view projections, now we have to proceed with the evaluation of edge view, top view projections of this particular lamina. Now here we have got the projections of the points R dash and P dash. They are projected as R and P into the top view projections. Similarly, point A dash will be projected as point A into the edge view projections over here. Similarly, the points T dash, D dash and B dash, they are going to coincide with each other as the observer is going to look at these 3 points from the top. So in the top view, these 3 points, they will be projected as T, D and B into the top view projections, and all of these 3 points, they are going to coincide with each other. Then we have got corresponding to the point C dash, the top view projections of this point C dash, they will be obtained onto the edge view as point C over here. And finally, the projections of the points or the corners S dash and Q dash in the front view, so they will be projected as S and Q onto the top view projection. So this way we have been able to obtain the edge view projections of this lamina onto the horizontal plane. And now, since the distance of this lamina from the vertical plane has not been defined, so we can take any arbitrary distance to locate these edge view projections onto the horizontal plane. So this distance we have assumed to be any arbitrary distance, right? So we can choose any suitable distance so that we can locate the top view projections of this lamina onto the horizontal plane below the XY reference line. Now, having obtained the top view projections in the form of edge view projections onto the horizontal plane, now we know that the surface of this lamina, it is inclined at an angle of 30 degree to the vertical plane. And here we have to now rotate this edge view which we have just obtained over here at an orientation of 30 degree with respect to the vertical plane. So now this projection line we have drawn to begin with, and then we have marked all the points which we had obtained onto the edge view in the previous view in such a way that we have rotated this edge view at an angle of 30 degree. So the distance between R1, P1 and A1, it will be same as this distance, that is between RP and A. Similarly, distance between RP and T, D and B points, it will be this distance. So this distance we are going to mark it over here, and same distance has to be obtained into the top view projections of this particular lamina which is inclined at an angle of 30 degree with respect to VP. So similarly, the point C1 will also be located. That is distance between R1, P1 and C1. This will be equal to the distance between points RP and point C over here. So this way, all the 9 points, we can see 9 points they are existing onto this particular edge view. 5 points, that is P, Q, R, S and T, corresponding to the boundary of this lamina, and 4 points corresponding to the square hole which is existing within this particular lamina. So all these 9 points of the top view which are obtained onto the edge view projection, they will be transferred from the previous edge view which we had drawn earlier. Now, having obtained the top view projections in the edge view, now we are required to obtain the corresponding front view projections of this lamina which has been inclined at an angle of 30 degree with respect to the vertical plane. So how these front view apparent shape projections of this inclined lamina will be obtained? We are going to draw vertical projectors through these 9 points of the edge view in the upward direction, and the horizontal projectors through these 9 points we are going to mark from left to right, and wherever the intersection of the corresponding points will be obtained, so the 9 points of the apparent shape of the lamina which is inclined to the vertical plane at an angle of 30 degree will be obtained. Now here you can see, corresponding to these 9 points we have drawn 5 vertical projector lines from these plan projection points into the elevation projection view. Now we are going to draw the horizontal projector lines from these 9 points in such a way that the horizontal projector corresponding to a point should be intersecting with the vertical projector line corresponding to the plan projection of that particular point. So the intersection points will be providing us with the location of the elevation projection points in corresponding to this apparent shape view. So here we can see point T1 dash has been obtained by virtue of the intersection of the vertical projector line drawn through the point T1 over here and the horizontal projector line drawn through the point T dash from the previous elevation projection view. Similarly, now the 2 points R1 dash and S1 dash, they have been located. These points they have been obtained by virtue of the intersection of the corresponding plan and the elevation projection points over here. So we can see this is the point R1, that is plan projection point. Now from R1 we have taken the vertical perpendicular projector in the upward direction, and from point R dash, we have drawn a horizontal projector line. So wherever these two projector lines they have intersected, we have obtained the point R1 dash. Similarly, S1 dash point, it is the result of intersection of the vertical perpendicular projector drawn through the point S1. We can see this is point S1 and the horizontal projector line which we have drawn through the point S dash over here. So this way, intersection of these two projection lines, it has provided us with the location of the point S1 dash in the elevation projection view. Next, we have got point D1 dash over here. So this D1 dash point has been obtained as a result of intersection of these two projection lines. So the first vertical projection line is drawn through the point D1. So once we draw vertical projector line through the point D1 and we draw horizontal projector line through the point D dash. So wherever these two projector lines they intersect, we obtain the location of the point D1 dash over here. Similarly, A1 dash point, it is a result of intersection of vertical projector line drawn through the point A1 and horizontal projector line drawn through the point A dash over here. Similarly, C1 dash, so this point is also the result of the intersection of the projection line which has been drawn through the point C1. That is the vertical projector line which has been drawn through the point C1 and the horizontal projector line which has been drawn through the point C dash over here. Next, we have got point B dash. So this horizontal projector through the B dash, once we draw this projector, wherever it intersects with the vertical projector line drawn through the point B1. So this intersection point provides us with the location of the point B1 dash in the elevation view over here. Next, we have got these 2 points, P1 dash and Q1 dash. So here P1 dash point has been obtained by virtue of intersection of the vertical projector line drawn through the point P1 and the horizontal projector line drawn through the point P dash over here. Similarly, Q1 dash point has been obtained by virtue of intersection of the vertical projector line drawn through the point Q1 and the horizontal projector line drawn through the point Q dash. So these two projector lines they intersect at this position. So here we obtain the point Q1 dash. So this way, the apparent shape projections of this lamina, which is having a square hole located over here into this orientation, and these projections, they are the apparent length projections because this lamina or the surface of the lamina, it happens to be inclined with respect to the vertical plane at an angle of 30 degree. Now, one special characteristic we witness into these front view projections, that is the front view projection of this edge P1 dash and R1 dash. So this is still a true length over here. So this projection is still true length. Why? Because this is still parallel to the vertical plane. So this edge happens to be parallel to the vertical plane. So because the edge PR, it happens to be parallel to the vertical plane. So therefore P1 dash R1 dash, it is still the true length. Now the second orientation or inclination of this lamina is with respect to the side PR. So in the second instance, it has been provided to us that this lamina, it will be reoriented with respect to horizontal plane in such a way that the edge PR should be inclined at an angle of 45 degree with respect to the horizontal plane. So this apparent shape projection which we had obtained in the front view, so these apparent shape projections of all these 9 points, they will be rotated or reoriented at an angle of 45 degree into the front view projections in such a way that P1 dash and R1 dash edge of this particular lamina, it is this edge, P1 dash R1 dash edge of the lamina, it should be reoriented at an angle of 45 degree with respect to the horizontal plane. So now, using the principle of the rectilinear distances, we are going to transfer this apparent shape front view projections of this particular lamina in such a way that this figure will be reoriented, or it will be rotated at an angle of 45 degree with respect to the horizontal plane, and P1 dash and R1 dash edge will be lying onto this orientation line. So please see, here we have drawn this grid over here. So how we have gone about obtaining this grid? So please check. We know the distance between P1 dash and R1 dash. So this is the distance between P1 dash and R1 dash. So this point will be P2 dash. This point will be R2 dash. Is it clear? P2 dash and R2 dash. So this is the distance between P1 dash and Rn dash. And now from P1 dash, we measure this distance and draw a perpendicular line. So from this point, we measure this distance and draw this perpendicular line. You see, it is equal to P1 dash Q1 dash. So this is perpendicular to this edge, that is P1 dash R1 dash. Similarly, from R1 dash also, we draw a perpendicular projector in such a way that this distance, that is the distance between R1 dash and S1 dash, will be equal to distance between P1 dash and Q1 dash. So from P2 dash, if we draw a perpendicular projector, mark this point, so Q2 dash point will be obtained over here. Similarly, from R2 dash, this point, if we draw a perpendicular projector and mark the same distance, point S2 dash will be located. So this way, P2 dash, Q2 dash, R2 dash and S2 dash points, they have been located. Now, please check, from P1 dash, we measure this distance. So once we measure this distance, rectilinear, that is the horizontal distance. Now, we have been able to mark this point over here. And from this point, if we take this height, how much is this height? This is equal to 70 millimeter, 40 plus 30. So this distance is still true length over here. So from this point, we are going to measure 70 millimeter distance. So we are going to obtain this point as T2 dash. So please check, P2 dash, Q2 dash, R2 dash, S2 dash and T2 dash points, they have been obtained. Now we need to obtain inner points, that is A2 dash, B2 dash, C2 dash and D2 dash. Now we can check alongside this line, alongside this projector, we measure this distance. So B2 dash will be located. So one projection line we have drawn over here. So this distance is equal to this distance. So B2 dash can be located over here. Similarly, we have measured this distance as well. So once we measure this distance and draw this projection line, D2 dash point has also been located. Now, two vertical projector lines we have drawn corresponding to this distance, corresponding to this distance, and we have also marked the center line of this particular square hole which is there within this lamina. So please check, it is this height which we have marked over here. This is the height. So this height, once we mark this distance and this distance, we mark it corresponding to this one and this distance over here. So points A2 dash and C2 dash will be located over here, A2 dash and C2 dash. So this way, using rectilinear distances, we have been able to locate P2 dash, Q2 dash, R2 dash, S2 dash, T2 dash and then A2 dash, B2 dash, C2 dash and D2 dash points over here. So all the 9 points, they have been located using the rectilinear distances from the previous elevation projection view into the new orientation of the elevation projection view when this apparent shape projection of the lamina has been transferred or reoriented at an angle of 45 degree with respect to the horizontal plane. So we have got P2 dash, R2 dash edge of this lamina being reoriented at an angle of 45 degree. Now having obtained these 9 points of the elevation projection view which corresponds to the front view projections of the oblique lamina which happens to be inclined at an angle of 30 degree with respect to the vertical plane and 45 degree with respect to the horizontal plane. So the front view projections, they have been obtained. Now the corresponding projections of these 9 points into the top view projections we need to obtain. So how these top view projections will be obtained over here? From these 9 points in the elevation. These are the 9 points in the elevation. So from all of these 9 points, we are going to draw the vertical projector lines over here into the plan projection view. And from the previous plan projection view, now we are going to draw the horizontal projectors from left to right into the plan projection view. So wherever these vertical projector lines from the elevation projection view and the corresponding horizontal projector lines from the plan projection view, they will be intersecting, we will be able to obtain all the 9 points corresponding to this oblique lamina into the top view projections over here. So let us evaluate each one of these 9 points into the plan projection view. So first of all, we have drawn the horizontal projectors through these 9 points of the previous plan projection view. Now one by one we are going to draw the vertical projectors from each one of the elevation projection view and find out the corresponding points of intersection, right? So here we can see point P2 has been obtained by virtue of intersection of 2 projector lines. So which are these 2 projector lines? One is the vertical projector line emerging from the point P2 dash and horizontal projector line which is emerging from the point P1. Now this Q2 plan projection viewpoint, it has been located by virtue of intersection of 2 projection lines over here. And which are these 2 projection lines? One vertical projector line has been drawn through the point Q2 dash. This is the one. And another horizontal projector line has been drawn through the point Q1. So wherever these 2 projection lines they intersect, we obtain the point Q2 over here. Similarly, R2 point, it is the result of intersection of the vertical projector line which has been drawn through the point R2 dash and the horizontal projector line which has been drawn through the point R1. This is the point R1 over here, this one. So horizontal projector through R1, wherever it intersects with the vertical projector through the R2 dash. So we obtain the point R2 over here. Next we have got the point S. So corresponding to the point S2 dash, we have drawn a vertical projector line. Corresponding to the point S1, we have drawn a horizontal projector line. So the intersection of these 2 projector lines will provide us with the location of the point S2 over here. And finally the last point of this lamina, that is the boundary of the lamina, it is T point over here. So from T2 dash, we have drawn a vertical projector line, and from point T1, this is the point T1 over here, we have drawn a horizontal projector line. So wherever these 2 projector lines they intersect, we obtain the point T2 over here. So this way the 5 points of the boundary they have been obtained. And once we join these 5 points P, Q, R, S, T, so we will be able to obtain the boundary of this particular lamina. Now we have to obtain the 4 projection points corresponding to the square hole over here. That is the plan projection points corresponding to the square hole, they need to be obtained. So let us start with the point A2 dash. So from A2 dash, we have drawn a vertical projector downwards and we have extended this vertical projector from A2 dash till it intersects with the horizontal projector which has been drawn through the point A1. So this is the location of the point A1 in the edge view. Now from this A1 point, a horizontal projector has been drawn. So the intersection of these 2 projection lines, it has provided us with the point A2 over here. Now from the point B2 dash, again a vertical projector line has been drawn and it has been extended up to the limit where it is going to intersect with the horizontal projector line which has been drawn through the point B1. So the point B2 has also been obtained. Similarly, through C2 dash, if we draw a vertical projector in the downward direction, and from C1 we have drawn a horizontal projector line. So wherever these two projector lines, they are going to intersect. We have obtained the point C2 over here, and finally this is the point D2 dash corresponding to the front view projection. Now from D2 dash we have drawn a vertical projector line and extended it up to the limit where it is going to intersect with the horizontal projector line emerging from the point D1 over here. So this intersection of this projection line through D1 and this vertical projector line through D2 dash, it will provide us with the location of the point D2 corresponding to the square hole. Now we can check once we join A2, B2, C2 and D2. So we have obtained the top view projections of this oblique lamina, which is inclined to vertical plane at an angle of 30 degree and inclined with respect to horizontal plane at an angle of 45 degree. So this way, through this discussion, we have been able to evaluate the orthographic projections of the oblique lamina, which is having a square hole in this orientation, that is in the vertical orientation located over here. Now this oblique lamina happens to be inclined with respect to the vertical plane at an angle of 30 degree, and the edge PR of this particular lamina, it happens to be inclined with respect to the horizontal plane at an angle of 45 degree. So we have been able to obtain the orthographic projections of an oblique lamina which happen to be inclined with respect to vertical plane as well as the horizontal plane. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the planes in the coming lectures. So thank you very much. Thanks a lot.